Let's look at another example of a photoelectric effect experiment question. This time I would consider this a level 2 question. It is based on the same scenario that we looked at with our first example. It has light with a wavelength of 350 nanometer, hitting a surface producing 3.50 amperes of current, and it requires 1.90 volts to reduce the current to zero. The question now is, what is the speed of the emitted photoelectrons? Now, like most photoelectric effect experiment questions, really want to not rely on like a single formula that will give us an answer that we just find the right numbers, put them in the right places, and get our answer. It really requires an understanding of the experiment and the relationship between the different quantities. And this one's no different. If you consider what's going on here, they're describing a photoelectric surface, and there's an electron in the surface that we are shining light on, and the light has a certain wavelength. And because of that light hitting the surface, the light energy, well, it disappears. It gets absorbed by the electron, and now the electron, two things happen. The electron gets to the surface and it moves off with some kinetic energy. And the key is to the answering this question is this idea of kinetic energy, because in the experiment, kinetic energy can be thought of two ways. Kinetic energy is 1/2 mv squared. That's the usual kind of thought around kinetic energy of a massive particle moving with some speed. In the experiment, if you'll recall, the way the experimenters deduced or found the kinetic energy of the emitted photoelectrons was to apply a stopping voltage and then understand that the kinetic energy is Q times the stopping voltage. So it's the understanding of these two ways that we can see kinetic energy in this experiment, the traditional 1/2 mv squared formula, but also the experimental way of finding that kinetic energy, the Q times V stop, that allows us to solve this question. If we write the kinetic energy form of the equation 1/2 mv squared, and we say that is going to be equal to Q times V stop, then this is the starting point for this question. The recognition that these two formulas are really two ways of finding the same thing, the experimental way and then the traditional theoretical way of finding the kinetic energy of a massive particle. So the rest is the math part. 1/2 of the mass of the electron. It's a photoelectron, but as you should understand, photoelectrons no different than any other electron in the world. Here's my speed that I'm going to be looking for. So 1/2 the mass times speed squared should be equal to the Q. Now, told you last time, when you start putting equations or numbers into your equation, you ask yourself this question all the time. Do I want to use joule or do I want to use electron volts? This time, there is a part of this question that is going to make the decision for me, and it's this part right here, this idea of kinetic energy. When we solve kinetic energy using this classical physics equation, we always end up with units of joules. So we don't have any say in this matter now. When we calculate using stopping voltage and charge our kinetic energy, we need to use the joule form of the equation. So we have to use the charge as 1.60 times 10 to the minus 19 coulombs, and the stopping voltage is still 1.90 volts. But you'll see what will happen then on this side is I'll get units of coulombs times volts. So I'll get my joules that I want when I take a coulomb times a volt. If I wanted electron volts, I would have taken 1 electron times 1.90 volts. So all that's left to do is the math part of this. Let me grab my calculator and find out what I get. 1.6 times 10 to the minus 19 times 1.90 is 2 divided by 9.11 times 10 to the minus 31. Square root of that. I get an answer of 8.17 times 10 to the power of 5 meters per second. So going back to this level 2, I guess it's debatable, but I would call this a level 2 question because in a level 1 question, level 1 questions are questions that you get really familiar with. And the starting point that a lot of people get kind of hung up on, and it's not a bad, I mean, to go into photoelectric effect experiment questions, assuming that we're going to have to start with some law of conservation of energy where EP is equal to work function plus kinetic energy. If you start photoelectric effect experiment questions with that starting point, you know, 80% of the time you're on the right track. But then you get these ones that change it up a little bit, and I think this one requires really the conceptual understanding of what's going on with the experiment and the stopping voltage and how that relates to our traditional calculation of kinetic energy. Also, there's this hurdle that you have to jump, or this little pitfall of working with joules and electron volts. And just when you get used to thinking, hey, I can use whichever one I want as long as I'm consistent, then you get a question like this where your choice of units is made for you. When you take a kilogram and times it by a meter per second squared, or meter squared per second squared, you will always get joules. So you don't have a choice in this one. You must work with joules on this side of the equal sign if you're working with joules on this side. So to me, it's a level 2 question.